I don't know what you people are talking about right now, but. Learn something new every day.
I did not learn anything.
Let's learn some optimization.
Learning something new.
Yes, yay. Alright, so optimization means like finding maxes and mins. This is one of the reasons like so many different majors have to take calculus. This optimization idea, if you're looking into business, you want to be able to maximize your profits but minimize your costs, right? So there's a lot of those types of things. So we are looking at word problems in this. So our strategy, we need to be able to identify our variable, the thing that we're trying to maximize or minimize. We don't want to have multiple variables because then we would have to do implicit differentiation. Remember that was kind of ugly. So everything needs to be in terms of one variable. Okay, if there's multiple unknowns, find a way to get them all in terms of x. We might have to draw pictures to help us with that. Then we will find critical points. How do we find critical points?
Derivative.
Yep, derivative equal to 0. So if we're looking for the maximum or minimum, that is those critical points, just like we were doing when we graphed. And then we can answer our questions. So I think, did I put some extra blank slides for you?
Yes.
Okay. So here is our first one. And this was actually probably a problem we did in college algebra, but now we're going to do it with calculus. Well, good. It'll be fun learning again. A farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. What dimensions will maximize the area? So what should I do first?
Draw a picture.
Draw a picture. Okay, we have a rectangle. Okay, I'm only putting fence on 3 sides because the 4th side is a wall. Alright. I don't want to call my sides x and y because that's 2 variables. So we could do that for a second, but we need to figure out what y is. How could I do that? So that's the thing we're trying to maximize. And the area is length times width, so it's x times y currently. So before I do the derivative to maximize that, I would like to get rid of one of those variables. What other information do we have?
The wall.
Well, we have a wall. What does that mean?
The sides we have.
So when I add these sides, I only have to build a fence on 3 of them. That equals 200. So 2x plus y equals 200. So that missing side is 200 minus 2x. So use that here. If I plug that in, it's x times 200 minus 2x. So we get 200x minus 2x squared. So that's my area formula, as nice as it can be. And then if I ask you to find a maximum, what do we have to do?
Critical points.
Yep. How do we get critical points? So derivative of 200x would be 200 minus derivative of 2x squared would be 4x. And I want to set that equal to? So x is 50. Alright, most of the time we're only going to get a single answer on those. If you did get multiple, you could verify that it was a maximum, just like when we did sign lines to decide if things were maximums or minimums. If you plug in something smaller than 50 into our derivative, so if I put in like a 0, we get a positive. If I put in 100, I would get a negative, so it went from increasing to decreasing. So I could verify this is in fact a maximum. Am I done? No. Answer the question with a sentence. So I want the dimensions. So the pen should be 50, we were in yards, by, okay, y was 200 minus 2x.
100.
200 minus 2 times 50 is 100. that one okay? I want you to read the next one and see if you can draw a picture.
What is the
Like a fence.
bookshelf?
What do we have to draw first?
The rectangle.
Okay. I'm gonna choose. All right. Some of the fencing will be used to construct two inner divider fences, both parallel to the same sides. So they're both going the same direction, whichever direction you chose for that to be. All right. What is the maximum area of the corral? So I need to label if this is X and this is Y for a moment. This would be a Y and this would be an X. These would also be
X's.
So when I add them up, I get
4x times 2. Oh, plus.
yeah, sorry, I'm adding up to get my total fence, which is the 1,000. Okay, so we know that. We know that area is length times width, so that's still x times y, but we have to get rid of one of those variables. So let's solve for one of them.
Solve for.
I wrote. Okay, so if I want to solve for y, 2y is 1,000 minus 4x. Divide by 2, so y is 500. So my area, x times 500 minus 2x, gives me 500x minus 2x squared. Now what do we do?
Derivative.
500 minus 4x. We need the critical point, so when that's 0 or undefined, it's never undefined. So when 4x equals 500, and x is 125.
So what's the maximum possible total area of the entire world?
So how do we find the area from that?
Find y and then multiply them together.
Okay, you can either find your y and plug it back into xy, or you could plug it into the 500x minus 2x squared. Either way,
Okay.
we should get the same answer.
That seems easier. Never mind. 125.
Yeah, it would probably be easier to, nicer numbers if you found your y first. So to answer the question, the maximum area is 31,250 square meters.
Choir is dismissed at this time. Choir is dismissed at this time.
Is that okay? Let's do a couple more examples. A piece of sheet metal is rectangular, 5 feet long, and 8 feet wide. Label that as I go. Congruent squares are to be cut from its 4 corners. So I'm going to each corner and taking out a square.
What does congruent mean?
They're the same. So all the same size. The resulting piece of metal is to be folded and welded to form an open top box. Okay, so can you visualize that? When I cut out the squares. We did these in college algebra too, I think, and I stood up in front of the room and I tore the corners off a piece of paper. So if you cut those corners out, then you could fold these tabs up, so then it makes And open top, because I didn't create a lid to go with it.
I was confused on how the square, how. I thought the box.
Thanks.
I thought the box was gonna be square, end up square, so I couldn't.
Oh.
And I can't picture things in my head. So
Yeah.
it's bad.
I'm not a visual person either. Well, I can't just picture it in my head, I have to see it.
I can't picture anything in my brain, so
Okay,
I just be struggling.
so now, I want to maximize volume. What is volume?
Length times width times height.
Okay, so I need dimensions on this. Now, I know this side was 5, but we came in and we cut some off each end. Do I know how much?
No.
No, so if I, how many of those did I take off?
4 minus 4x. Oh, what? Hang on. I lied. I don't know what's happening.
Well, but just this side right here.
Oh, 2.
It was 5, and I took x off the left and x off the right, so I took off 2x. So now that length is 5 minus 2x. Okay, this one
Do I
was
need
8.
Is it pertinent to draw this 3D box?
I would for your labels,
I don't know.
perhaps. The middle one I feel like is fairly unimportant, but.
Oh, I drew that one though.
So if you had a length of 8 and you took x off each end, now it is.
How did you draw that? You're a magician.
So when you folded your box, the tab you folded up, the lengths of those were x. So how tall is this box? Just x. Just that, the length of that tab. So when I multiply these, we have x times 5 minus 2x times 8 minus 2x. Now we could do the derivative here, but we'll have to do product rule 3 times, so it might be nicer to multiply it out first. If I FOIL those. Then I get that the volume is 40x minus 26x squared plus 4x cubed. Now what do we do? So derivative of 40x is 40. Derivative of 26x squared would be 52x plus 12x squared. And I want to know when that is equal to 0. I'm going to flip it around so the square terms first. Okay. I'll just divide by 4 on both sides since I do have an equation. So this second side. What multiplies to 30?
Negative 3, negative 10.
Divide the 3 back. So we get x minus 1, 3x minus 2. Okay, if we set those equal to 0, I get positive 1 and positive 10 thirds. Okay, so are both answers reasonable? Seems reasonable.
I feel like 1 is too.
Why is 10 thirds too big? If it's 5, remember the width of our piece of metal was 5 to start with. 10 thirds is 3 1/3. Can you take 3 1/3 off both ends? No. So 10 thirds is too big here. Also, would it have made sense if we got a negative?
No.
No, so we need to always check. And then the question was, how should this be done to maximize volume? So the squares
PLA testing stuff.
Okay.
Okay. I need to make sure, just needed to make sure it wasn't like today and I didn't do my.
We need to do ours together.
Oh yeah, because they changed it to where
What's happening?
apparently people were cheating on the FBA test, so like they would have so many people in the same event, and they would take the test, and then they like write down answers or something, and then the next person would give their score, and the next person would give their score from the same school.
So they want us to take, if we have it in the same category, like me and Sarah both doing manage, or what was it?
So we have seen several times the C of X representing the cost function. And we've talked about marginal cost being the derivative of that. So the marginal cost function, so I guess I meant to put is
No.
a derivative, sorry. I left off a couple words of the cost function. So marginal cost is a derivative of cost. So in marketing, you're not only concerned about your cost. Okay, we also need to worry not just how much is it going to cost me to produce this, but I have to decide what price should I be charging my consumers. So the demand function, also known as your price function, is typically denoted with a lowercase p. So price is lowercase p. C is cost. Then you can find revenue. What does revenue?
How much you're making?
The amount of money you're bringing in. So revenue is just X times price. The number of items you sell times the price you're charging per item. All right, then we might need to know marginal revenue. So marginal revenue tells us how the revenue is changing. So marginal revenue would be the derivative of revenue.
I took a business class online, and we were supposed to do this, but I had to geek out.
Oh,
This is making a lot more sense.
good, good. Would have helped if you'd seen this before your business class.
It was sophomore year too.
Oh yeah, you would have had no idea. That was helpful. How do we find profit?
The cost minus the revenue. By the way, revenue minus cost.
Unfortunate notation, but they typically use capital P for profit and lowercase p for price. So profit is revenue minus cost, the amount you bring in minus the amount you spend. And then marginal profit would of course be
The derivative.
the derivative of profit. Yeah, or R prime minus C prime. if you wanted. All right, so I'm only going to do one example using this stuff today, and then we'll pick up with it on Monday. Tuesday. Yes. All right. Suppose the cost of publishing a book is $10,000 to set up the press run, plus $8 for each book printed. Can you tell me what the cost would be then? Can you give me the equation, the cost function?
10,000 plus
AX plus
You
10,000.
were right, I was just the wrong way.
Well, it doesn't matter. Addition's commutative. It could be either way. So just a linear function. You pay the $10,000 one time to set it up, and then you have $8 for every book. Okay. The publisher sold 7,000 copies last year for $13 each. But sales dropped to 5,000 copies this year when the price was $15 each. Okay, this is talking about the price, right? So what I just gave you are two ordered pairs. When I look at this X, X is the number of books. Okay, that's what it represents in this equation that we wrote for cost, so that's what it has to represent throughout. So if I want to write an ordered pair, my number of books would be my X, my price would be my Y. So 7,000, comma, 13 would be one ordered pair. And what's the second ordered pair?
5,015.
Okay, can we write the price equation from that?
Mm-hmm.
Yeah, we need to find our slope. y2 minus y1 for x2 minus x1. Gives you 2 over negative 2,000, so negative 1 over 1,000. So if you plug into y equals mx plus b, always use the first point. Y is m times x plus b. So my b is 20. So my price equation, lowercase p, negative 1 over 1,000 x plus 20. So here's the information we have so far. We have cost, we have price. Let's see what else it gives us. Assuming up to 10,000 copies can be printed in a single press run. What does that tell me?
You max.
Right, the max is 10,000. If I go over 10,000, this whole equation changes. How many copies should be printed, and what should be the selling price per copy to maximize this year's profit? So I'm trying to maximize profit. So I need a profit equation. How do we find profit? We have to do revenue minus cost. So first we need to get revenue. How do you find revenue?
X times profit.
Or times price.
Oh, yeah, this is going.
I know, isn't that unfortunate? I did not make that part up. Okay, so x times our price function. So my revenue is negative 1 over 1,000 x squared plus 20x. Okay.
You're not allowed to move it.
Yeah, apparently it just wants it to stay. So there's my revenue. I want to maximize profit. So now I need profit first. Then we can maximize. How do you find profit?
Revenue minus cost.
The amount of money you bring in minus the amount of money you spend. So my revenue, 1 over 1,000 x squared plus 20x minus cost, ax plus 10,000. Can I distribute my negative and combine my terms at the same time? So 20 minus 8 would be a 12x minus 10,000. Okay, so I have all of the equations we could want now. This is the one that I was going for because now I have to maximize this, so we do the derivative. So 2 comes down, so negative 1 over 500x. Derivative of 12x would be 12, and I need to know when this is 0.
Oh, sorry.
So I would have 1 over 500x equals 12.
Negative 12, right?
Oh, I added this over and flipped my sides at the same time.
Oh, back up.
Okay, and we get 6,000. So I asked 2 questions. How many copies should be printed? So there should be X was the number of books, so that's my 6,000 copies. And what should the price be? Yeah, if you subtract over the 12.
The price should be $14.
And how do we get that?
Put it into the price equation.
Good labeling is helpful here. So if I come back to my price,
Carson is done for.
Carson, they have no faith in you.
0.
So negative 6 plus 20 is 14. So our price is $14.
What
the price equation. I took the X value we got
Oh, okay.
and I plugged that X into our price function. All right, so that was long. The math isn't all that hard, but it's just a lot to keep track of. Because we've got cost, revenue, profit,
What was the last number?
$14. All right. Any questions? So let's try some problems.